Hello guys, welcome back to ZTC, your go-to destination for demystifying the complexities of tech. Have you ever wondered how your devices seamlessly connect to the digital universe? Well, you're in the right place because today, we're unraveling the mysteries of networking devices. Let's get started. What are network devices? A network device is a piece of hardware or software integral to communication between a computer and an internet network. Network devices play a crucial role in establishing a network connection, as a router or a modem does. Functions of network devices facilitate data transmission and communication between devices, enable efficient and secure network connectivity, provide network security by enforcing access control and threat prevention, extend network coverage, and overcome signal limitations. Types of network devices. Networking devices come in various types, each serving specific functions within a computer network. Here are some common types of networking devices: switches, bridges, routers, firewalls, repeaters, gateways, hubs, modems, network interface cards, NIC, wireless access point. What is switch? Switch is a network device that is used to segment the networks into different subnetworks called subnets or LAN segments. It is responsible for filtering and forwarding the packets between LAN segments based on MAC address. Switches have many ports, and when data arrives at any port, the destination address is examined first and some checks are also done, and then it is processed to the devices. Different types of communication are supported here like unicast, multicast, and broadcast communication. Types of switches. Virtual switches. A virtual switch is a software program, a logical switching fabric that emulates a switch as a Layer 2 network device. A virtual switch ensures the same functions as a regular switch, with the exception of some advanced functionalities. Namely, unlike physical switches, a virtual switch does not learn the MAC addresses of transit traffic from the external network, does not participate in spanning tree protocols, cannot create a network loop for redundant network connection. VMware's virtual switches are called switches. Switches are used for ensuring connections between virtual machines, as well as connecting virtual and physical networks. A vSwitch uses a physical network adapter, also called NIC, Network Interface Controller, of the ESXi host for connection to the physical network. Routing switches. Routing switches, also known as Layer 3 switches, are network devices that combine the functionality of traditional switches with routing capabilities. Unlike standard switches that operate primarily at the data link layer, Layer 2 of the OSI model, routing switches can make forwarding decisions based on IP addresses, similar to routers, which operate at the network layer, Layer 3. Unmanaged switches. Unmanaged switches are basic network devices that connect Ethernet devices together, allowing them to communicate with each other. They are a simple and affordable solution for expanding a small home or office network. Unlike managed switches, unmanaged switches offer no configuration options. They are truly plug-and-play devices, meaning you simply connect them to your network and they start working automatically. Managed switches. Managed switches are network devices offering advanced features like remote configuration, VLAN support for network segmentation, quality of service, QoS, for prioritizing traffic, spanning tree protocol, STP, for preventing loops, port mirroring for monitoring, and security measures such as access control lists, ACLs, and port security. They also support link aggregation, LACP, for increased bandwidth and redundancy. These switches are remotely manageable, making them ideal for businesses needing greater control and security in their networks. How does a network switch work? When the source wants to send the data packet to the destination, the packet first enters the switch, and the switch reads its header and finds the MAC address of the destination to identify the device. Then it sends the packet out through the appropriate ports that lead to the destination devices. Switch establishes a temporary connection between the source and destination for communication and terminates the connection once the conversation is done. Also, it offers full bandwidth to network traffic going to and from a device simultaneously to reduce collision. What is a bridge? The bridge is a networking device in a computer network that is used to connect multiple LANs to a larger LAN. In computer networks, we have multiple networking devices, such as bridges, hubs, routers, switches, etc. Each device has its own specification and is used for a particular purpose. A bridge in a computer network is a device used to connect multiple LANs together with a larger local area network LAN. The mechanism of network aggregation is known as bridging. The bridge is a physical or hardware device, but operates at the OSI model's data link layer and is also known as a layer of two switches. Types of bridges. There are three types of bridges in computer networks, which are as follows. Transparent bridge. A transparent bridge is a common type of bridge that observes incoming network traffic to identify media access control, MAC, addresses. These bridges operate in a way that is transparent to all the network's connected hosts. A transparent bridge records MAC addresses in a table that is much like a routing table and evaluates that information whenever a packet is routed toward its location. A transparent bridge may also combine several different bridges to better inspect incoming traffic. Transparent bridges are implemented primarily in Ethernet networks. Source routing bridge. Source routing bridges were developed and designed by IBM specifically for token ring networks. The frame's entire route is embedded with the data frames by the source station to perform the routing operation, so that once the frame is forwarded, it must follow a specific defined path/route. Translational bridge. Translational bridges convert the received data from one networking system to another, or it is used to communicate or transmit data between two different types of networking systems. Like if we are sending data from a token ring to an Ethernet cable, the translational cable will be used to connect both the networking system and transmit data. What is router? A router is a device like a switch that routes data packets based on their IP addresses. The router is mainly a network layer device. Routers normally connect LANs and WANs and have a dynamically updating routing table based on which they make decisions on routing the data packets. How does router work? A router analyzes a destination IP address of a given packet header and compares it with a routing table to decide the packet's next path. The list of routing tables provides directions to transfer the data to a particular network destination. They have a set of rules that compute the best path to forward the data to the given IP address. Routers use a modem such as a cable, fiber, or DSL modem to allow communication between other devices and the Internet. Most of the routers have several ports to connect different devices to the Internet at the same time. It uses the routing tables to determine where to send data and from where the traffic is coming. Types of routers. Broadband routers. Broadband routers are devices used to connect multiple devices to the Internet using a broadband connection, such as DSL, cable, or fiber optic. These routers serve as the central hub for distributing Internet connectivity to various devices within a home or office network. Wireless routers. Wireless routers are a type of networking device that allows multiple devices to connect to the Internet and communicate with each other wirelessly through Wi-Fi technology. These routers serve as the central hub for distributing Internet connectivity to various wireless-enabled devices within a home or office network. Wired routers. A wired router is a networking device that forwards data packets between computer networks using wired connections, such as Ethernet cables. It serves as the central point of connection for multiple devices within a local area network, LAN, or across multiple LANs. Virtual router. A virtual router is a software-based emulation of a traditional hardware router, operating within a virtualized environment on standard computing hardware or cloud-based platforms. It replicates the functionalities of a physical router, including packet forwarding, routing table management, and network address translation, NAT. Virtual routers offer flexibility and scalability, allowing multiple instances to run on a single physical machine, thus optimizing resource utilization and enabling efficient network provisioning. They are integral components of virtualized networking environments such as data centers, cloud computing platforms, and network function virtualization, NFV deployments. What is firewall? A firewall is a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block specific traffic based on a defined set of security rules. Firewalls have been a first line of defense in network security for over 25 years. They establish a barrier between secured and controlled internal networks that can be trusted and untrusted outside networks, such as the Internet. A firewall can be hardware, software, software as a service, SaaS, public cloud, or private cloud. Types of firewall: stateless or packet filtering firewall. A packet filtering firewall protects the network by analyzing traffic in the transport protocol layer, where applications can communicate with each other using specific protocols. Transmission Control Protocol, TCP, and User Datagram Protocol, UDP. These firewall examines the data packets at this layer, looking for malicious code that can infect the network or device. If a data packet is identified as a potential threat, the firewall rejects it. Small businesses that need basic protection from existing cyber threats can benefit from a packet filtering firewall. Stateful inspection firewall. Stateful inspection firewalls operate at the gateway between systems behind the firewall and resources outside the enterprise network. Stateful inspection firewalls are situated at layers 3 and 4 of the Open Systems Interconnection (OSI) model. State-aware firewalls examine each packet, stateful inspection, and track and monitor the state of active network connections while analyzing incoming traffic for potential risks. The state is the most recent or immediate status of a process or application. Stateful firewalls can detect attempts by unauthorized individuals to access a network, as well as analyze the data within packets to see if they contain malicious code. Application-level gateway, it also referred to as a proxy firewall, serves as an intermediate between internal and external systems. An application-level gateway operates at the application layer, the highest of the OSI model. It employs deep packet inspection, DPI, on incoming traffic to check both data packet payloads, content, and headers. This firewall makes sure that only valid data exists at the application level before allowing it to pass through. Application-level gateways follow a set of application-specific policies to determine which communications are allowed to pass to and from an application. They help protect a network by masking clients' requests before sending them to the host. Next-generation firewall, NGFW. A next-generation firewall, NGFW, is the only type of firewall that provides the capabilities to protect modern businesses against emerging cyber threats. As malware and threats have become more difficult to detect at the access point, NGFW security has evolved to span the network and monitor behavior and intent. NGFWs provide functions like deep packet inspection, intrusion prevention, IPS, advanced malware detection, application control, and provide overall network visibility through inspection of encrypted traffic. They can be found anywhere from an on-premises network edge to its internal boundaries, and can also be employed on public or private cloud networks. What is a repeater? Repeaters are defined as a networking device that is used to amplify and generate the incoming signal. Repeaters work at the physical layer of the OSI model. The main aim of using a repeater is to increase the networking distance by increasing the strength and quality of signals. The performance of local area networks, LANs, and wide area networks, WANs repeaters are used. Using repeaters helps to reduce error and loss of data and provides with delivery of data at specified locations only. The major advantage of using a repeater is that it provides with transfer of data with more security and over a long distance. Types of repeaters. According to the functions and features, repeaters are divided into 3 types. They are as follows. According to the type of signal being generated by the repeater, they are classified as analog repeater. Analog repeaters are used to amplify only the analog signals. Analog repeaters receives the analog signal, amplifies it, and then regenerates it as the output. Analog repeaters were mostly used in the older network technologies, where analog signal was used. Digital repeater. Digital repeaters are the type of repeaters that does not amplify digital signal, but regenerates it directly. Digital repeaters are mostly used in the modern technologies where digital signal is being used. Digital repeaters are also capable to reconstruct a distorted signal. Based on the type of network the repeaters can connect, they are categorized as below. Wired repeaters. Wired repeaters are used in wired local area networks (LANs). Wired repeater receives the signal and repeats it. This helps to extend the network travel data without losing its strength and data. Wireless repeaters. Wireless repeaters are used in wireless local area networks (LANs) and cellular networks. A router connected in the network sends wireless signal to the repeater. Once received, repeater broadcasts the signal to increase the coverage of network. How does repeater works? A repeater is a device that amplifies or regenerates a digital signal as it passes through it, allowing the signal to travel further without losing strength or integrity. It receives a weak or corrupted signal on one network segment and retransmits it on another segment, effectively extending the reach of the network. The repeater listens to the incoming signal on one of its ports, amplifies it, and then sends the amplified signal out of its other port. This process is done in real time, and it is transparent to the devices connected to the network. They don't need to be aware that the signal is being repeated. What is gateway? A network gateway is a device or node that connects disparate networks by translating communications from one protocol to another. Network gateway devices serve as entry and exit points for data traffic between different networks, providing connectivity, routing, and security functions. These devices facilitate communication between devices within a network and between different networks, such as local area networks, LANs, wide area networks, WANs, and the Internet. What is a modem? Modem stands for modulator/demodulator. The modem is defined as a networking device that is used to connect devices connected in the network to the Internet. The main function of a modem is to convert the analog signals that come from telephone wire into a digital form. In digital form, these converted signals are stored in the form of zeros and ones. The modem can perform both the task of modulation and demodulation simultaneously. Modems are majorly used to transfer digital data in personal systems. The modem is also known as a signal translator, as it translates one signal into another signal by modulating the digital signal into an analog signal for transmission, and then demodulates receiving analog signals into digital signals. Working of modem. A modem works by converting digital signals into analog signals and vice versa. The modem consists of two main components, the modulator and the demodulator. The modulator is responsible for converting digital signals into analog signals, while the demodulator is responsible for converting analog signals into digital signals. When a user sends data from the computer, the modem converts the digital signals into analog signals that can be transmitted over the communication channel. The modem sends the analog signal over the telephone line, cable line, or wireless network to the receiving modem. The receiving modem then decodes the analog signal back into digital signals that can be read by the computer or digital device. Types of modem. There are different types of modems available. Each modem has different features and provides with different benefits. Optical modem. In modem, different type of media is used to transfer the signals. Optical modem is the type of modem that makes use of optical cables instead of using another metallic type of media. The digital data is converted into the pulse of light that is transmitted on the optical fiber used in the optical modem. Optical modems are commonly used in telecommunications networks, broadband internet connections, and other applications where high-speed data transmission over long distances is required. Digital modem. Digital modem is defined as a type of modem that is used to convert digital data into digital signals. Digital data is in form of zeros and ones. For this, it performs the process of modulation. Digital modem modulates the digital data on digital carrier signals for transmission. Cable modem. Cable modems are defined as a type of modem used to establish a communication between computer systems and the internet service providers. A cable modem helps to access high-speed data through cable TV networks. Such modems are usually connected to desktops or systems and work like external devices. Satellite modem. Satellite modems are defined as a type of modem that provides with the internet connection through satellite dishes. This type of modem works by sending the input bits into output radio signals and vice versa. The internet network that is provided by such types of modems is more reliable and efficient as compared to other types of modems. Dial modem. A dial modem is a type of modem that converts data used in telephone and data used on computers. In short, dial modem converts between analog form and digital form. The networking devices connected to the computer are all at one end, and the telephone line is at another end. This type of modem transmits the data at a speed of 56,000 per /sec. What is the hub? A hub is a common connection point, also known as a network hub, which is used for connection of devices in a network. It works as a central connection for all the devices that are connected through a hub. The hub has numerous ports. If a packet reaches at one port, it is able to see by all the segments of the network due to a packet is copied to the other ports. A network hub has no routing tables or intelligence, unlike a network switch or router, which is used to send information and broadcast all network data across each and every connection. Although most of the hubs can recognize network troubles or errors like collisions, broadcasting all information to the several ports can be a security risk and cause bottlenecks. The network hubs were popular in the past time as they were cheaper as compared to a switch or router. Nowadays, switches are much cheaper than a hub and provide a better solution for any network. Furthermore, a hub is no IP address, as it is a dumb device. Types of hub. There are three types of the hub that are given below. Passive hub. The passive hubs are the connection point for wires that helps to make the physical network. It is capable of determining the bugs and faulty hardware. Simply, it accepts the packet over a port and circulates it to all ports. It includes connectors, 10-base-2 port and RJ45, that can be applied as a standard in your network. This connector is connected to all local area network (LAN) devices. Additionally, the advanced passive hubs have AUI ports, which are connected as the transceiver according to the network design. Active hub. As compared to a passive hub, it includes some additional features. It is able to monitor the data sent to the connected devices. It plays an important role between the connected devices with the help of stored technology, where it checks the data to be sent and decides which packet to send first. It has the ability to fix the damaged packets when packets are sending, and also able to hold the direction of the rest of the packets and distribute them. Intelligent hub. It is a little smarter than passive and active hubs. These hubs have some kinds of management software that help to analyze the problem in the network and resolve them. It is beneficial to expand the business in networking. The management can assign users that help to work more quickly and share a common pool efficiently by using intelligent hubs. However, it offers better performance for the local area network. Furthermore, with any physical device, if any problem is detected, it is able to detect this problem easily. Working of hub. A hub receives data and then sends it in full to all connected devices, hosts. All ports of the hub operate at the same speed and are located in a collision domain. A hub does not offer the option to control or exclude only individual receivers. This means that all data packets are always forwarded to all computers during a transfer. This means that even those devices the data wasn't intended for also receive the data. Since all hosts are occupied in this way, the other devices cannot send any data themselves in the meantime. If you need more hosts, you can connect one hub to another hub. This connection is created with a simple crossover cable over one of the ports. However, the number of hosts is automatically limited by the 5-to-4-3 rule or repeater rule. This states that a maximum of 5 segments with 4 repeaters can be used between 2 end devices. What is NIC? NIC stands for Network Interface Card. It is a hardware component that allows a computer or other device to connect to a network. NICs are typically installed internally on a computer's motherboard or connected externally via a USB port or other interface. The NIC facilitates communication between the device and the network by converting data from the computer into a format that can be transmitted over the network and vice versa. It also handles tasks such as error checking and packet framing. Essentially, the NIC serves as the interface between the computer and the network, enabling the device to send and receive data over the network. Functions of Network Interface Card. NIC definition is very simple, but what does a Network Interface Card do, and what is the function of NIC? Working as an interface at the TCP/IP layer, An NIC card can transmit signals at the physical layer and deliver data packets at the network layer. No matter what layer the network interface controller lies, it acts as a middleman between a computer/server and a data network. When a user requests a web page, the LAN card gets data from the user device and sends them to the server on the Internet, then receives the required data back from the Internet to display for users. Types of NIC cards. Wired NIC. It connects to the network using a physical cable, such as an Ethernet cable. It is a common and widely used type of NIC in desktop computers, servers, and other devices that require high-speed and reliable network connectivity. Wired NICs can provide high-speed network connections with low latency, making them suitable for applications that require large data transfers, real-time communications, and online gaming. They are also typically more reliable than wireless NICs, as they are not subject to interference or signal loss. A wireless NIC connects to the network using Wi-Fi technology. Wireless NICs offer mobility and flexibility, making them suitable for portable devices such as laptops, smartphones, and tablets. They can provide network connectivity in areas where physical connections are not available or practical, such as in public spaces or outdoor areas. Wireless NIC. It connects to the network using Wi-Fi technology. Wireless NICs offer mobility and flexibility, making them suitable for portable devices such as laptops, smartphones, and tablets. They can provide network connectivity in areas where physical connections are not available or practical, such as in public spaces or outdoor areas. Wireless NICs can transmit data over short to medium distances, and their speed and reliability depend on the quality of the wireless signal. USB NIC. It is an NIC that connects to the device via a USB port. It allows a device to connect to a network using a standard USB port, which is typically found on most computers and laptops. USB NICs are relatively easy to install and use, making them a popular choice for people who need to quickly and easily add network connectivity to a device. They are also relatively inexpensive, making them an affordable option for those on a budget. What is Wireless Access Point, WAP? It is a networking device that allows connecting the devices with the wired network. A wireless access point, WAP, is used to create the WLAN, Wireless Local Area Network. It is commonly used in large offices and buildings which have expanded businesses. It is easier and simpler to understand and implant the device. It can be fixed, mobile, or hybrid proliferated in the 21st century. The availability, confidentiality, and integrity of the communication and network are a responsibility and to be ensured about that. A wireless AP connects the wired networks to the wireless client. It eases access to the network for mobile users, which increases productivity and reduces the infrastructure cost. Need of wireless access point. Wireless access points, WAPs, are essential components in modern networking environments, as they provide wireless connectivity to devices without the need for physical cables. They enable the flexibility and mobility that characterize today's digital world, allowing laptops, smartphones, tablets, and other wireless devices to access network resources and the Internet from anywhere within their coverage range. WAPs facilitate seamless communication and collaboration in offices, homes, public spaces, and educational institutions, enhancing productivity and convenience. Without WAPs, users would be restricted to wired connections, limiting their mobility and hindering the scalability and flexibility of network deployments, especially in dynamic environments where devices frequently move or change location. How does a WAP work? When you connect a WAP to a network, it creates a wireless local area network, WLAN, by broadcasting a wireless signal. This signal can be picked up by compatible devices within its range. When you want to connect to the network, you simply need to select the appropriate wireless network name service set identifier, SSID, and enter the password if required. The WAP then acts as a bridge between the wireless devices and the wired network, allowing data to flow between them.